goes up to 63?
Oh, because if the thing would be much farther than that, you wouldn't even bother doing that, any of this stuff. Yeah. The Merkach, I mean, the Chal, that's awfully wide. Anyway, the Tosefos Maslul is okay. The Tosefos Maslul, we add that to the Emtza Maslul, and we get another number, another intermediate number, which we call Maslul nothing, if I'm not mistaken.
Nothing?
Yeah, nothing.
Okay.
Okay. So you now add the Tosefos Maslul. Maslul means like path, but you know these numbers are kind of these names are kind of confusing because they don't to Maslul. Maslul, remember, is the bicycle, how far around the bicycle wheel it is, right?
Yeah, with the flag.
Right. You get then
Maslul's a small wheel? Yeah.
No.
And you get the manus Maslul, right?
No.
Alright, now once you have Maslul and Nachain, now you can use the table on page 11. Using this Maslul and Nachain, use that as the input to determine what the output, which is this the Manasa Maslul, or Manasa Maslul, however you want to pronounce it. You get that, and that, once you add that to the Yareach, or subtract it from the Yareach according to the rules that are given, then you have the Makama, then you have...
what are those rules?
Huh?
What are those rules?
I'll explain in a little while. Let's just put this down. Alright.
You add an asmasul or you subtract it?
Depends on where it is, which side of the road it is. And you have Makamamiti. That's it. See, 8 simple steps.
That's it.
Okay. That gives you the whole move. Now, if you look at briefly on page 11, it shows you a little bit about how complicated all this geometry is. That, on page 11, there's a diagram that I drew there, which I copied out of another book that I found. And basically, the Maslul and Nachain, these are all just different slight corrections of the angle to give us where the moon is from the point of view of E. E is the guy in the earth. C is the center of the moon's Emtsoi circle. P is a point that's the same distance away from E as E is from C.
On the same line.
Huh?
On the same line, or it just happens to be?
On the same line. No, it's that point on the same line. So those three.
Why is P for what?
Huh? It's just for a mathematical reason. When you
That was the doubling earlier.
when you extend those lines like that, it's not really. When you extend those lines like that, you get those 3 little lines near A and R up there on the end of the little guy. All right, so basically you do a whole bunch of trigonometry and geometry and work all this stuff out, and you get the Tosefos Maslul that we had from page 10 is the distance between A and R. Okay.
Brilliant.
A and R is the line from P through O. A is the line from E through O. So that little difference there is the Tosefos Maslul we talked about. Then the Maslul and Nachain is from A to the moon. Then
The moon is where? Oh?
the moon is where it says moon. See, it says moon there.
Okay.
Yeah. So basically all this stuff is very complicated, but the cookbook that the Rambam has cooked up for you is fairly simple. You just look up the 2 things in these 2 tables, plug them in, and you got the Makam Amiti.
And you find O by the angle from C, right?
O is simply, it's your plain old, simple, old Emtsoi. Alright, now, everybody's probably a little bit confused. I don't blame you for being a little bit confused, but it's not that hard. Now we're going to do the example, and you'll see how it all fits together. This is the example the Rambam uses. I got lost in which parak I'm in now. But, okay, right now we're going to do, all right, we just did basically parak 14 of 15, and the end of parak Tesvav. That's where we're now going to do that example from the end of parak Tesvav, which is the 29-day thing. And that's going to be used for the rest of the whole Kiddush Hachodesh, the 29-day thing. Okay, let's take a look on page 12. 29 days after the Iker, which was Beis Ear, tough, what is it? Tough, whatever. Okay. We got to figure out the Shemesh. Stick your fingers over to page 6 and 7.
You have that already?
Huh?
You have that already?
Yes, I do. Okay, keep a finger on page 12. You might want to work this out yourself. It's very, very simple to do the arithmetic yourself. You can work it out yourself, but you will see how brilliant and easy this is, the way the Rambam made this. I mean, and I'm telling you, this is very, very complicated stuff. Nobody knows this kind of stuff. And scientists, you go to a guy who's a physicist or something like that, unless he specializes in this kind of astronomy, nobody knows this stuff. Rambam has made it so that, what?
Can you take step 9 again?
Huh?
What's step 9?
Add or subtract the manas hamaslo from the makam amiti, and you get the makam emtsoi, and you get the makam amiti.
I didn't know to add or subtract.
We'll discuss
If
that.
it's more than 180, then you can subtract.
Yeah, it depends. There's some rules here. The Rambam says them in Parak Tesvav. I don't know if I might have neglected to write them down here, which I think I possibly did. But you can see, if you look at that diagram that I made on page 11, you can see how if the thing is added or subtracted. Is the angle going to be bigger or smaller depending on where the moon is? Okay. Anyway, let's do the example and you'll see how simple this is really. Okay. Let's figure out the shemesh. Okay. Everybody, look at page 6. Got it? Huh? Keep your finger on page 12. Just glance at page 6. We're going to go 29 days after the Iker. What's 29 days? It's an addition of 28 degrees, 35 chalakim, 1 shniya. Okay, I wrote that down.
34.2
Huh?
34.2
34 what?
34.2
Huh?
I worked it out over here.
No. Okay. The Iker, 7:32:32, 7:3:32. I'm sorry. That's on page. That's on page 7 in the middle. Add them together. You get 35, 38, 33. See page 12? Does everybody understand that? 32 plus 1 is 33. 33 plus 35 plus 3 is 38. 720 is 35. No carrying, nothing. That's the Emsa Shemesh for the day that we're worried about, 29 days later. Got it?
Yeah.
Simple. Next, Yereach. Go to page 9. These are the tables that are written in the Rambam has these long things. If this is between this and this, it's this. I just copied them to a table form here on the page so that it's easier to look stuff up. Okay. All right. Now, Emsa Yereach. Emsa Yereach in 29 days. How far does it move? 22,656. See that? On page 9. Where was it at the Iker? 31, 14, 43. Add them together. You get 53, 21, 39. Why is it 39? 4, 5 is 9. Because the 43 plus 56 gives you 99, right? So you have to carry,
Carries over.
So you have to carry over 1 second, one minute. Take away 60, you get 39. Everybody understand Yereach and say Yereach? Simple calculation. Just add them together. Rate times time is this. What's the rate? The rate is 22,656. That's actually rate times time. And the Iker, where did you start? 31, 14, 43. There you get. Now the moon Emsa Yereach was 53, 21, 39. Okay? However, when was this? We got to correct for sunset. Look at page 10. Take the Vakam HaShemesh Shemesh is around 35, 36 degrees, right? Where does it fit? It's between 15 and 60.
Yes, it's 15.
Huh?
We have the.
So use
I added
15 halakim, 15 minutes of arc. So you add the 15 down there, and I have in a little box in the middle of page 12, 56, 36, 39. That's the Emsa Yureach B'Shas Re'iyah. Got it? Good. Simple. Now go back to page 9. Let's do the bicycle tire. That's the Emsa Maslo. 29 days. How far does it move? 18, 53, 4. Where did it start? 84, 28, 42. Add them together. Back to page 12. Add them together. 42 plus 4, 46. 28, 53. It gives you 81 really. So you have to carry over one degree over to the left, and you subtract 6. You got 21. So 84 plus 18 plus 1 is 103. So there we have the Emsa Maslo. That's the bicycle tires at 103 degrees. 21 minutes, 46. Now we do this mysterious thing called figuring out the merchak. Merchak is moon minus sun. I just copied the stuff from Yureach here. 53, 36, 39. Minus, that's the Shasari, minus the sun, 35, 38, 33. By the way, we didn't correct the sun for sunset, did we?
No.
Because the sun moves so slowly, the correction is not relevant. It won't make any difference. Okay, so we end up subtracting and we get this merchak being 1758.6. All right? Now, just roughly speaking, that's the distance in the angle between the sun and the moon, 17 degrees, which sounds like a lot. That's, more than a day's worth of moon movement. So maybe you should be able to see the moon. The problem is that we can't really tell because these are uncorrected for the makam amiti. So therefore, we don't really. The makam amiti might subtract a couple of degrees either side of them and make it within the limits that you wouldn't be able to determine it. Okay. Now go to. So I have this merchak. What is the merchak? The difference is 1758. It's almost 18 degrees, right? 1758.6. Multiply it by 2.
Yeah.
Multiply it by 2. All right. How do you multiply? Well, you do the same thing as multiply in English, except you just, when you get over 60, you got to move stuff to the next column to the left. So 2 times 6 is 12. 2 times 58 is normally 108, right? But we subtract out 50, we got 60, we got 100. I'm sorry, 2 times 58 is 116. We subtract off 60, we got 56. 2 times 17 is 34. Add the carried over degree, 35 degrees, 56.12. That's the merchak kafel. Go back to our table on page.
10.
Where is that page? 10.
And at the bottom.
10 at the bottom. Look up that amount. Where is it in that table?
32 to 38.
Huh?
32 to 38.
Good. So it's 5 degrees is the Tesefes HaMaslo. Okay? So we add that 5 degrees to the maslo. Did we do the maslo yet?
Yeah. Yeah, he did it further up.
Oh, right, all right. It was 103.21.46. Add 5 to it. You got 108.21.46. Easy. As long as you just follow the rules.
Now,
Try to figure out why it's doing
five
this.
twice.
Huh?
Yes.
No, just to add it once. So add 5 to the 103, you got 108. This is exactly what the Rambam is doing, by the way, in where is it here? I should have put down the place where it is. This is in the bottom of the end of Parak Tesvav. Okay. What?
That's the bottom of 12.
Huh?
Page 12 is the bottom.
Yeah. Okay. All right. So now we got the Masla Nachim. Now we use this Masla Nachim as the basis for looking up something else, right? We look at, what is our instructions again? From the Masla Nachim, we use that to the table on page 11. So we find page 11.
Find the minus.
Masla Nachim is 108.21.46, right? So that's over between 100 and 110.
Each one is 1.
Huh? So 100 was 5 degrees 8 minutes. it reduced to 4 degrees 59, so it's about 9 chalakim between the two of them, and we're 8/10 of the way through there. So we do, huh? So for 10 degrees of maslul, the mana decreases by 9. So we get about
A little bit less than 1.
huh? So we get about 5 degrees 1 chelik is the correct answer. Let's look on page 13. This is called the interpolation, where you try to figure out the value in between, knowing the two extremes and how they move, how they change between the two. You see on page 13 there?
Yeah. Where'd you get the 7 from?
Where I get the who from?
The 7 minutes.
Oh, I said because, right, for 10 degrees of maslul, the mana decreases by 9, right? So we have here, we want to find for 108, right, which is 8/10 of the way through there. So, so basically, I said that for each degree it reduces by 0.9. So 8 times 0.9 is 0.72, right? Huh?
You say so.
Each degree is moving by how much? Each degree moves the maslul by how much? Huh?
A little bit less than 1.
Look,
Yeah,
10 degrees of maslul, the mana decreases by 9 chalakim. So every degree it's going by 0.9. It's going down by 0.9, right?
Yeah.
So 0.9, and we want to find 108, which is 8
8 times 9 is
8 times 9 is 72. So I just put 0.7. 7, yeah, right. So I got rid of the 0.2.
Yeah.
So 5 degrees 8 minus 7. 7 chalakim is 5 degrees 1.
So the minus mass will be 5/1.
Yeah. And that is the correction to the makam ha'yireach b'shas riyah. And it's subtracted here. And we get 48, 35, 39, which is 48, 36 when we round it up.
Why is it subtracted?
Huh?
Why is it subtracted?
Okay. Why is it subtracted? I thought you were going to ask me that question. Okay.
Because you just say add or subtract on the board, but
Yeah, okay. All right. If you look on this picture here, on page 11, this ugly picture. Okay, if the moon is going to be, to the right of the makam emtsoi, which means it's less than the correction is going to be subtracted from the makam emtsoi, right?
okay.
You see that? Huh?
That'll be further down.
What?
That'll be further down.
It's to the right. Yeah, this is the zero. Zero is over here. We're counting degrees this way, right? So we see, if you could see, if there were some heavenly body at the makam emtsoi, and then the moon would be to the right of it. It would have less number of degrees in its position than the makam emtsoi, right?
So you have to find the makam emtsoi and see if the moon is to the right or the left.
Well, that comes out from this, from the way this is. Now, if the okay. In Perek Tesvav, Halacha Daled, it says, "V'achar kach tira kama mailas hu b'maslu nothing." Im hayach is b'kuf pei. If it's less than 180, then tigra manas hamaslu hazah hanachim yemtza yireach l'shas riyah. That's the picture that I have here. You see? That's the moon is going to be to the right.
Yeah.
All right. See where I show you what masl hanachim is? It really is how far it is.
From the moon to A.
Huh? From the moon to A,
yeah.
which is the line of sight of the guy through the makam emtsoi.
Right.
Okay, so that masla nothing, if that is to the right of it, then the guy is looking. He's going to see it less degrees than the makam emtsoi. Okay, So it's less than 180. Anywhere, 180 goes from here all the way to here. 0 to 180, whatever it is. That's anywhere to the right. You're going to subtract off that correction because it's the moon is to the right of the Makam Amiti. If it's between 180 and 360 on the other side of the circle, you're going to have to add it.
You basically draw a line through the circle that will bisect the circle.
Yeah, but there's a bunch of lines there. Let's not get too involved in the lines there. But that's the general feeling for it is that if you're on the right side of it, then the guy who's
The right
looking
side of this.
the right side of this line through the earth, through the center of
Anywhere here will be subtraction.
yeah, that's right. Yeah, because you're looking
And
forward.
that's the line from the guy's perspective, not the center or the peak, but from the E.
It's from the guy going through the makam.
From the E going through the O.
Yeah, yeah.
And the O is the makima
I'm sorry.
and Sai.
Yeah. So this is our correction to the makam that gives you makam amiti. And then we've done it. We've done the makam amiti. We found the position of the Arayach, which is, as I read you in the astronomy book, one of the hardest things to do in this kind of calculation.
What comes after?
Huh?
What comes after?
Okay. Now the next thing we have to worry about is the Rosh, not the Rosh Shiva, but and there was a during the 1948 war in Eretz Yisrael, there was a kibbutz that somebody shot down an Arab airplane with a rifle. He managed somehow to shoot this rifle, and he killed the pilot or something like that, or blew out the engine or something like that, and the airplane crashed. And I think even to this day in this kibbutz, there is this airplane, the wreckage of the airplane with, as a monument to the fact that this guy. The thing is that every single guy in the kibbutz claimed credit for having shut down the airplane. You go to any of these guys around and yeah, I'm the one who shot it down. They all complain. So when Rabbi Shochat came here 25 years ago or so, I believe I was the one who actually named him the Rosh. But I seem to remember me calling him the Rosh and people catching up, but I might be mistaken. Might be the other guy. Anyway, the Rosh. What did I call the Rosh the other day? The Rosh was the place, the number of degrees along the Emtsai Yareach circle, actually the true orbit of the moon, where the moon's orbit goes above the ecliptic, going north.
The 5 degrees up
Huh?
or down.
What?
5 degrees up or down.
Yeah, it eventually gets to 5 degrees high, and then it comes back down. Just the same as the other one goes 23 up and then down. Likewise, this one is going around that thing, which is inclined at 23.5 degrees. It's going up and down. Where it goes north is called the Rosh. Where it goes south is called the Zonav. The Rosh is always 180 degrees from the Zonav.
Wait, so
That's 5 degrees.
basically the circle is on the line.
If you would have two rings, two hoops of the exact same size, and you could somehow fit them so that they intersected each other. One has to be a little bit smaller to fit in the other one. You would see that they intersect at 2 points.
But it goes at the highest point. It's 5 degrees above.
That's right.
But it's half the year it's above.
No, every month it goes above and
Half
below.
the month it's above.
Half the month is above, half the month is below. And the places where it intersects, is called the Rosh and the Zonav. Has the same kind of rules as all these other Emtsoi kind of things. That's the beginning of Perek Tez Zayin.
Wait, so the farthest the moon could be straight overhead is about 5 degrees north of
5 degrees north of 23 degrees.
the Tropic of Cancer?
Yes. In other words, if you have a full moon, let's say it's the first day of winter, December 21st, a full moon, if there is a full moon at that date or around that date, the moon will be the farthest north it can be. Because the sun is the farthest south, and it's on the opposite side. And if the moon at that time happens to be Reichav, which is the distance north of the ecliptic or not, its biggest Reichav of 5 degrees, it could be 28 degrees north. We're about 34 degrees. See, we're sticking up at an angle of 34 degrees, and that would be at about 28 degrees, almost overhead.
Still south.
Yeah. Now, you might say, well, I see sometimes the moon is north of me, right? Like if you go outside sometimes, you look and see the moon, when it's rising, it could be very far north. That's because we're sticking up on an angle and the Earth is round, and we can sort of see
Down the hill.
north, down the hill, around the curvature. It really isn't north, because when it comes straight north-south line from us, then that's where the true, then you could actually measure the angles. That's, by the way, how they figure out how big the Earth is. Huh?
I thought you meant
Do
the
the
curvature.
Huh? No, what you do is you take a stick and you put it in the ground, measure the shadow at one place. Then you go a known distance somewhere away. You measure the shadow there, north or south of it. From the difference in the shadows with trigonometry, you can figure out the size of the radius of the Earth has to be able to make that difference. But I saw this other book here where they did this kind of measurement in various places, but I don't want to go into it right now. Let's go through the Rosh here, okay? The Rosh is called in English the ascending node, N-O-D-E. Ascending means it's going north, going up. The point which the path of the moon crosses the path of the sun going north. The tail is the Zonov, is 180 degrees the other side. Exactly opposite. The Rosh, if you go from month to month, where does the moon cross? You'll find that the value decreases. We normally count everything going this way, but the Rosh seems to move backwards. The place where it crosses, that doesn't mean the moon is going backwards. The Rosh is not where the moon is. We figured out already where the moon is going around this thing. We've done the Makam Amiti. We know that it increases every day about 13 degrees. However, the place where it crosses, that's going backwards. It's sort of like, if you ever put a plate on the table and it goes around like, it spins around. It's sort of that kind of thing. You have two plates, or the plate of the moon sort of is like rolling around, and as a result, the places where it crosses the sun's path, that moves back slowly. But the moon itself is going this way. It's just that as it comes around, the places where it's like sewing, it's going above and below. Where it comes around, that place seems to be going backwards of where it is. It isn't really the moon itself is going forwards, but the place where it crosses is going backwards.
That's every 7 years it goes back a degree or so?
Pardon?
That's every 7 years?
No, that's different. That basically is the Goiva Shemesh that we were talking about before. That's the reason for the Goiva Shemesh moving around this way is because the zero is moving backwards by the same amount. That's why the Goiva Shemesh is increasing, because the zero is going. What's the matter? You don't like that? Okay, anyway, let's just do the Rosh very quickly. It's the same kind of thing. That's what's so easy about this. Look in the middle here. This is just Perik Tez Zayin.
Is there an Iker?
Huh? Yep. At the Iker, way at the bottom of the page on page 13. Iker of the Rosh, the Iker of the Rosh was at 180, 57,
So
28.
it's pretty much half.
Huh? Yeah. Okay. The movement of the Rosh, one day is 3 minutes 11 backwards. In 10 days, blah, blah, blah. 29 days, what we're worried about, 1 degree 32.9. So let's find the moment.